In this video, we're talking about inverse operations and the fact that addition and subtraction are inverse operations and multiplication and division are inverse operations. And the way that we illustrate an inverse operation is, let's take, for example, an addition problem. We have 7 plus 4. We know that 7 plus 4 is equal to 11. The fact that addition and subtraction are inverse operations tells us that if we then start with 11 and subtract 4, we should get back to 7, the number that we started with. And of course, we can see that that's true. If we say 11 minus 4, we get 7. So in other words, if we start with 7 and we add 4, we get to 11. If we then start with 11 and we subtract 4, we get back to 7. So you can see here what's left is the positive 4 and the negative 4. Those are opposite numbers. So that tells us that addition and subtraction are inverse operations. We can do another example here where we start with subtraction. So we're going to start with 6 and we're going to subtract 2. 6 minus 2 we know is 4. Now if we start with 4 and we add the 2 back in, of course we're going to get back to 6, the original number that we started with. So you can see here we started with 6 and subtracted 2 and ended up with 4. Here if we start with 4 and we add 2, we get back to 6. So basically when you take a number out and add it back in, you're going to get back to the same thing. What we could say too is if we start with any number, let's just put in a placeholder. Let's call this number x. We're going to start with just some value. If we add 4 and then we subtract 4, so if we add 4 and then we subtract 4, what are we going to get? Plus 4 minus 4 is just 0. This is going to go away, and we just have x plus 0. We know that 0 is the identity number for addition, which means that if we add 0 to anything, we don't actually change the value of the thing that we started with. So x plus 0 doesn't change the value of x, we still just end up with x. Same thing here with this second example. We just started with some value. This time we'll call it a. We started with 6, but we'll just put in a placeholder and call it a to illustrate the point that we could start with anything at all. It doesn't matter what it is. If we start with something and we subtract 2 first, and then we add 2 back in, the negative 2 and the positive 2 cancel with each other, and we just have a plus 0, a plus nothing. We haven't changed it at all, and we still just end up with a. So this is to illustrate that addition and subtraction are inverse operations. Adding something and then subtracting it back out, or subtracting something out and then adding it back in, isn't going to change the value of whatever it was we started with. Well, multiplication and division are the same way. So in this case, if we start with 3 and we multiply it by 5, 3 times 5 gives us 15. Then if we start with 15 and we divide 5 back out, we of course get back to 3. 15 divided by 5 is 3. So in other words, we started with 3 and we got to 15, or we can start with 15 and dividing by 5 we get back to 3. We can also do this backwards and start with division. If this time we start with 20 and we divide, 20 divided by 10 we know gives us 2. So we started with 20, we got to 2. But if instead we start with 2 and we this time multiply by 10, we're going to get back to 20. 2 times 10 is 20, so we get back to the same number, 20. So what this tells us again is that if we start with any number at all, it doesn't matter what it is, any value, in this case we started with 3, but if we start with anything, we'll call it x, and we multiply by 5, and then we divide by 5, divided by 5. Because multiplication and division are inverse operations, multiplying by 5 and then dividing out by 5, these two are going to cancel with each other, and we're just going to be left with x. And another reason we know that is because remember over here we said that the identity number for addition was 0. If we add 0 to something, we're still just going to be left with that original value. Adding 0 doesn't change the value at all. Well, when we're dealing with multiplication, multiplying by 1 is the identity number for multiplication. Multiplying by 1 isn't going to change the value. And if we rearrange this here, x times 5 divided by 5, we can call it x times 5 divided by 5. Remember, when we have a fraction here, we say 5 divided by 5. So essentially we've said x times 5 divided by 5. Well, 5 over 5, we know from fractions, is just 1. So this is essentially x times 1, which we know is just x. That's why this doesn't change, because when we multiply by 5 and then divide by 5, it's like multiplying by 1. And since 1 is the identity number for multiplication, we know that multiplying by 1 doesn't change the original value. So here we still ended up with x. And we can do it the opposite way too. If we started with 20, and we'll just call this a, if we start with any number at all, and we divide by 10, so dividing by 10, and then we multiply back in by 10, dividing and then multiplying again by the same number isn't going to change anything because that's just like this example here, multiplying by 10 and dividing by 10. We're still just going to end up with a. It doesn't change the original value. So that's how we show that multiplication and division are inverse operations in the same way that addition and subtraction are inverse operations.